Good morning. Good morning, everybody. This is Engineer Suraj Singh speaking for Bharat India on this day, March 1st, 2022, and Tuesday. This time 3:50 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक मार्च 1 2022 मंगलवार 3:51। Quality projects works, coordination engineering, communication, concrete, civil field engineering, reliable engineers, work contracts, SHE, designs, construction methods, and claims is the titles of today's talk. As usual, of course, you can see my email ID here, suraj_engineer@yahoo.co.uk, suraj_engineer@yahoo.co.uk, chartered engineer certificate, engineers professional engineer certificate that I have, and usually it is PE certificate, IPE, International Professional Engineer certificate here, and it is here chartered engineer certificate as usual, and this is fellow certificate of II, and this is my coordination engineering file, and this is my quality engineering file that I usually demonstrate to you, and also this is here my book cover. This was published. And I close FI file also time being, and the book cover just to show this was my handwritten work in 92 to 96. It was published in 96, and these buildings were just all drawn sketches without no computers. This was book written by me, originally based on field experience, construction experience. No copying, nothing, just doing sketches, writing experience, that, and these certifications. And now coordination engineering projects, public and engineers, an issue of high concern. I close this file also for time being, and we are now here. What is coordination engineering projects, public? If you want to go on browsing this, you can browse it and see it has got in this, and I'm just trying to show you contents of this file which are current. Every day I make some amendment to this. Some amendments are made. So yesterday also I made some amendments. I'll try to talk on that. It's a very important item from technical and coordination viewpoint, which you have to do, and that's very very important because it is viewpoint. How to, yes, it is here. Let us see. It's building management, as we discussed before also. You can say this provisional means it's not completely done yet, but let's see how it works. Now what it says, here is, it is continuation. It is building management systems. So what about that? What do you mean by building and management system? That is to say, building management, that's a kind of support support automation, support building services, how to operate, what to operate. Now, what it says, let's see. It's having taken from some source, that's the internet. Though I have used this in one project. It's a BMS, and that is Building Management Support, Building Management System, being most commonly implemented in large projects, not small one, but large projects with extensive mechanical, HVAC, and electrical system. Usually, you see, in buildings we have mechanical services, we have HVAC services. HVAC stands for heat, ventilation, and air conditioning, and electrical systems. And nowadays, more are there: gas supply systems, gas systems, you can say, and these are security systems. And so many more have been added. But these are main, which are required to be installed in every building. Actually, these are air conditioning, mechanical is left is mechanical. Also, plumbing is classified as mechanical these days, and of course, electrical system, which is very important: high power, medium power, low power, or low voltage, medium voltage, high voltage. You can say we have sometimes linked to transformers or substations, switch gears and transformers, and systems linked to BMS. Now, whose systems? Well, we have to link these systems to BMS, that is Building Management System. And typically means indicatively it is, and it says it represents about 40% of building's energy usage. If it is only something, and if light is also added, if illumination load is also included, this number may increase to 70%, but 40% is minimum. So let us say lighting is included, so this becomes 70%, and this building management system represented, abbreviated as BMS, is being critical component. Of course, it is critical component to manage energy demand. Now it says BMS itself is a system which is very critical, and this has to be managed. It manages energy demand. Now, improperly configured, if you don't construct properly, improperly configured BMS, building management systems, are believed to account for 20%. Means only 20% of building energy uses, or approximately 8% of total energy uses in the United States. So that's different. It's only now what we think about this, we have to study that. But think about, in addition to controlling buildings' internal environment, BMS, I am speaking BMS, which means Building Management System, are sometimes linked to access control. Access control. That is turnstiles and access doors. Turnstiles and access doors, controlling for purpose. Here is, sorry for that. I was just like to that. In addition to controlling building internal environment, you can say systems are sometimes linked to access control. That is turnstiles and access doors. Now, Let us watch on styles. Access doors has that. Access doors we know. Turnstile is a metal gate that moves around in a circle. When it is pushed and allows one person at a time to enter a place. So that's turnstile. And this is what we say sometimes, it has to be clear one. So we can start. I'm saying this turnstile, and this says. In addition to controlling buildings' internal environment, building management systems are sometimes linked to access control, that is round one or metallic gate, turnstile that is revolves, and access doors. Access doors, of course, having a purpose about who is allowed access and egress to building that we know very well, or other security systems that we provide whatsoever, such as closed circuit TV, that's also security system, CCTV we call it, and motion detectors, FE system, that's called fire alarm system, and elevators are also sometimes linked to BMS. It depends. They are linked for purpose of monitoring. In case certain fire is detected, let us say a fire is detected, then only fire alarm panel could close dampers. It is fire alarm panel, FA panel, could close dampers. Dampers means volume controlled dampers. In ventilation system to stop smoke, that is HVAC system, ventilation is there as well. A supply air ventilation system, then we VCD volume control dampers in ventilation system to stop smoke spreading. Shut down air handlers. I mean to say connected to air handling. Start smoke evacuation, fans, and send all elevators to ground floor. So what's that? And park them to prevent people from using them. So what is that? Let us repeat. In case certain fire is detected by smoke detector, some fire is detected, only fire alarm panel could you close dampers in ventilation system to stop smoke spreading, shut down air handlers, smart smoke evacuation, fans, and send all elevators to ground floor and park them so that nobody should use them. So what it says, the paragraph is important in the sense, let us repeat that. In addition to controlling buildings' internal environment, we are talking occupied environment. In addition to controlling buildings' internal environment, building management systems are sometimes linked to access control, turnstiles, and access doors, controlling for purpose about who is allowed access and egress to building, or other security systems such as closed circuit television, CCTV, and motion detectors. Fire alarm panel, fire alarm system, and elevators are also sometimes linked to BMS for monitoring. In case certain fire is detected, only fire alarm panel could close the dampers in ventilation system to stop smoke spread, shut down air handlers, start smoke evacuation, fans, and send all elevators to ground floor and park them, prevent people from using them. So let's move further on this. How it says, it's something very, I'm sorry, yeah. Building management systems have also included disaster response mechanism. Disaster response mechanisms such as base isolation. That says building management systems have also included disaster response mechanisms such as base isolation to save structures from earthquakes. In more recent times, companies and governments have been working to find similar solutions for flood zones and coastal areas at risk to rising sea levels. One such example is SAF, Safe Building System. There's some printers, arcs, packs, one apps. INC, which is designed to float buildings, roadways, and utilities in a few feet of water. Safe. It's we have to better understand this in a proper way. Let us see if we can find that safe building system. Sometimes we have to effort like that. Safe. Now, what is safe building system? Let's understand first of all. It's a size topic of article. Oh, like wait a minute. It's called. Let's say it's also known as SAFE foundation system, developed by architect and inventor Greg Henderson and its team at Arc Pax Labs INC is a way to build flood zones and coastal areas. It's designed to float buildings, roadways, and utilities in a few feet of water. Self-adjusting floating environment draws from existing technologies used to float concrete bridges and runs. The what's that? Self-adjusting floating environment draws from existing technologies used to float concrete bridges and runways such as Washington SR 520 and Japan's Mega Float. It also absorbs shock of earthquakes, allowing buildings and their related communities to remain stable. ArcSpax is working with Republic of Kiribati and Pacific Rising to solve for sustainable development challenges associated with rising sea levels. ArcPax company involved in this technology has proposed building a floating village project in North San Francisco, deploying a group of pontoons beneath building to protect development from floods and earthquakes. So this is some system, not this just for information, which was originally developed for earthquakes as an alternative to base isolation. A floating foundation decouples structure from earth with a simple patented methods consisting of three parts according to patent. Three-part foundation systems can include a containment vessel which constrains a buffer medium to an area above, containment vessel, and a construction platform. A building can be built on construction platform in a particular embodiment. During operation, construction platform structures built on construction platform can float on buffer medium. In an earthquake, a construction platform floating on buffer medium may experience greatly reduced shear forces. In a flood, a construction platform floating on a buffer medium can be configured to rise as water level rise to. We can say it's just explanation only. State building. And let's say if we can take this as let me show you if you can see that it's better just for a hard purpose. Safe building system, you may look at that, and I'm not going to save it, but let's see if you can read that. It's only reference. The safe building system it is, and it is here. You can see just can safe building system as from Wikipedia, and if you wish you can. It was in October 2000 21. So it's recent, you can say current one. And what it says, you can see that uh, this is ArcSpac company originally by this is what I told you. Once again I read, originally developed for the earthquakes as an alternative to base isolation, floating foundation decouples a structure, floating foundation decouples a structure from earth with a simple patented method consisting of three parts. Was that three-part foundation system can include a containment vessel which constrains a buffer medium to an area above containment vessel and a construction platform. A building can be built on construction platform in a particular embodiment during operation. Construction platform and structures built on construction platform can float on buffer medium. In an earthquake, a construction platform floating on buffer medium may experience greatly reduced shear forces. In a flood, construction platform floating on buffer medium can be configured to raise water level rise to limit flood. So this is what we said here. Safe building system. This was an architect Craig Henderson and his team Architects Labs to build in flood zones and coastal areas, float buildings, roadways, and utilities, and that's a self-adjusting float environment draws from existing technology used to float concrete bridges and runways such as Washington's. Okay, leave it now. We go back to something else, and that is here you can see. Let's go back and see something else if you can't get it. And in same way, same building, we go to see here maybe some more information. Architects is same, there's no meaning at all. Idly life safety system, building design, secure signal controls, nothing else. Let's close this. We go back to our talk here and we see how does it work. Coordination engineering helps us, and we can say that's it now. So we talk about this building management system, safe building system, as you said before. So we have covered that safe building system, and now it is safe building systems by Architects Lab, which is designed to float buildings, roadways, and utilities in a few feet of water. Now, self-adjusting floating environment draws from existing technologies used to float concrete bridges and runways such as Washington SR 520 and Chapel Mega Float. Now, there's another one on November 2019 or 11 2019. A security research paper was released titled "I Own Your Building Management System" by Jico Christic and Spec Melina that addressed more than 100 vulnerabilities affecting various BMS and access control solutions by various vendors. So this is what is that? Let us say this is I own your building management system. I own your building management system, and that's also an important point you have to see. I own your building management system. I own your building management system. Let us see how does it work. This is level number 92 which I am searching for, and it comes in, I think, let's say it's PDF form. Maybe it is no, it's not PDF, it's document form, so we'll convert to PDF, no issue. It is, I think, quite big. Well, 132 pages. I'll just browse for you. It's better if I browse for you. If I could, this is building management system security research. It is, and it's just contents I'll show you and nothing else. After that, we'll see how does it work. It's actually a document, and we'll see. It will take some time, and let us see how does it work. Just I show you this book. It's the important point, and I'll save it later on. It's important that it takes some little time in PDF format. This is, I use a PDF. This is a doc form. Let PDF come in. I can't show you words because this is PDF time. And I own your building. I own your building management system, security research, classification public, applied risk, number 11, 2029, and this is exploit DV. This is exploit DV. table of contents are. This is what is BMS, cyber security of BMS, and says cyber security of BMS. Let me see, where is that? In this document, and research scope and objective, methodology, and key findings, number of accessible BMS solutions insecure by design, most repeating issues, and this is you can say case 1, Nortec line immerse ET series, and there may be other cases. Then let's come. It's taking a lot of time. I think we should go by this time back to our study before we can do something is better. I'll come back to this now. What it says here: Ionic building management system. This is job acoustic and spike melena that addressed more than 100 vulnerabilities affecting various BMS and access control solutions by various vendors. So CBus is a communication protocol based on a 7 layers OSI model for home and building automation. It can handle cable length up to 1000 meters using Cat5 cable. It's used in Australia, New Zealand, Asia, Middle East, Russia, United States, South Africa, UK, and other parts of Europe, including Greece and Romania. CBus was created by Clipsal Australia, Clipsal Integrated Systems. I got this other it's not coming in yet. I'm not sure. It's not coming in. There is some problem here. I don't know what's that. It's not working, I think. It's not working. I failed, I think, in this case. Let's see, it's not working. It's not coming down. It's a PDF file. I think it's PDF file. Is it? Yes, it's a PDF file. It's PDF file 4746 chapter. It's okay. 4764 BMS site and BMS. So we can see that this is here, this is here, and this is here, and this is here. That's it. This is here, and this is Ionic management. This is. PDF is already here, you know. Oh, this is PDF, yes, it is PDF. No, it is PDF. I see. That's the phone. So say that's called is now is open. We can say I own this. You can say I own your building management system. It is, and as I said earlier, let's go how it works. So let us see index of this. No, it's disclaimer. Leave it. No problem. Okay, copyright. All right. Okay, I'm just referring to not talking introduction with this, and you can say not many people have noticed that modern buildings have changed into industrial control system. This introduction, I'll read this. I'm not going to tell everything, but not many people have noticed that modern buildings have changed into industrial control systems by embedding IP-based technologies throughout buildings and by connecting sensors, controllers, and supervisory software. Building owners enjoy a low-cost management of their assets with minimal safe staffing. Building management system monitor control a building's internal environment used to various sectors such as commercial, banking, industrial, medical, and even residential. Some solutions provide web interfaces to administrative panel which operators can connect to, and then unfortunately it's observed that these panels are often accessible from internet enabling also malicious parties to access administrators' dashboard. Multi-deployments of BMS solutions remain susceptible to basic cybersecurity attacks such as command injection, file uploads, and privilege escalation. Execution of these attacks enables an unauthenticated attacker to access and manipulate doors, elevators, air conditioning systems, cameras, boilers, lights, safety alarm systems in an entire building. This is as BMS solutions are at heart of many critical infrastructures. The security is vital. This report addresses problems of weak cybersecurity of BMS. First scope of problem is analyzed before weakness of 5 different BMS components of 4 different vendors are investigated. Vulnerabilities described in this document alone would affect more than 10 million people. So here is medical hospital building, hospitality is medicals, banking, and this is retail, and here is residential, let us say industrial commercial, whatever it is now. The question is, what is BM? Let's say from this viewpoint, building management systems are intelligent microprocessors based controller networks installed to monitor and control buildings technical systems and services. So intelligent microprocessors based controller networks installed to monitor and control buildings technical systems and services. Now here's an example it shows in this figure. I just refer to you. This figure shows examples of components that can be controlled with a BMS. Security cameras, car leaders, carbon dioxide sensors, temperature sensors, fans and boilers. BMS subsystems link functionality of these individual pieces of equipment so that they operate as one complete integrated system. Examples of this systems are presented as include video management system, access control system, fire alarm and suppression system, heating, ventilation, air conditioning control systems, and power, lighting, and elevator systems. Subsystems of BMS. Now, let's say here's an internet. It's a management level. It's called here. Internet is to firewall, and there's server and web browser here, and there's gateways and this automation controller. In this gateway and in this automation control, we have here carbon dioxide temperature sensors, fans and boilers, and in automation control, cameras, card readers, and door controllers. Just for reference, and how many layers are here? You can say it is security cameras here, and access control system, fire alarm suppression, heating and ventilation controller system, power, lighting control systems we have here. Now its examples: BMS is an access control system which restricts physical entry to only users with authentication and authorization. Many commercial, health, government, industrial, private organizations use access control system to manage physical entries into their facilities. Whether simple non-intelligent access control system such as entering a password or PIN or using Vignard card, HID reader, or advanced biometric systems which identify users and validate authorization permit entry. There are many advantages. Some types of access controls are used electrical, devices like electronic door access controllers, EDAC, which can be connected to many other devices, including door locks, fingerprint readers, elevator doors, cameras, gate automation. These systems can provide a variety of functionalities in a centralized solution to manage access for an entire organization. Now, cybersecurity of BMS. Modern BMS solutions use open communication protocols, what enables integration of systems from multiple vendors. This also increases risk of malicious parties finding zero-day exploits. Also, current generation of BMS is web-enabled, which makes them accessible from wherever in world. Remote access to BMS components allows for easy management of a building with minimal staffing. Number of devices accessible directly from internet is increasing as users and integrators of BMS solutions tend to prioritize this or that. No. Now, what actually some of risk to increase ability to Water is remotely lock or unlock doors and gates. And this is remotely lock or unlock doors and gates, control physical access of restricted areas, control elevator access, deny service, shutdown access controller, steal personal identifiable information, track movement patterns by viewing access logs, compromise other systems on network, manipulate video surveillance stream, manipulate alarms, spoof identifies or clone Vanguard cards, disrupt operations by malicious software propagation, create a botnet to perform other types of attacks such as DDoS, and this is some of risk include to ability. Yeah, these are risks there, and we can say that cyber security attack. It says given their exposure to the internet, these components can be accessed by whosoever from anywhere or whoever involved with little or no effort in exploiting discovered vulnerabilities to wreak havoc via targeted cybersecurity attack that can have huge impact on availability, integrity, and confidentiality of devices. And these risks are, as I said, remotely all these risks you have read. Then once compromised, an attacker can have a foothold on an entire premise and can perform some very dangerous actions. In this document, research paper, I'm not going to do that because it's copyright issue. Just trying to show you what are the objectives of this, and it is objectives here. So only I'm trying to show you this documents. I'm not going to discuss anyway because this is a question of copyright. So we'll see. If you want, you can download and read it. I'm just trying to show you number of it's nothing to do with my talk. Just I wanted to show you the various case studies in this, and I'm not going to waste time on that because these are not related. That's complete technical involvement, and just for you I have shown. If you wish, you can download yourself and see. And the site is general, no, not my own. So as you can see there yourself. So I'm going to close it. There's nothing in that. So what I've told you is enough for us for time being. And you can say, so it's nothing to do with that. So let us close it. There's no other way in this. And let's go back to talk. So we just reached a stage. So we are talking here. And we were, we talked of this system here. And I think, sorry, not this one, other one. So here's there. Now what I said in this is regarding this CBS list, talking of CBS. CBus is a communication protocol. CBus is a communication protocol. That's an important one. Let me, okay, it's already, let's 180 here. I put it this more. CBus is a communications protocol based on a 7-layer OSI model for home and building automation. They can handle cable length up to 1000 meters using Cat5 cable. It's used in various countries as given here. No need of that, we can read. And other parts of Europe, including Greece and Roma. So CBus, can say, CBus was created by Clipsal, Australia's Clipsal integrated. Okay, leave it. Let's go CBus briefly available in the United States. Now, CBus is used in control of domotics, a home automation system, and domotics. CBus is used in control of domotics or home automation systems, as well as commercial building, lighting control system. So commercial building, lighting control system, unlike more common extend protocols which uses a signal imposed upon AC power line. AC power line signals extend protocol which uses a signal imposed upon AC power line. CBus uses a dedicated low voltage cable or two-way wireless network to carry command and control signals. This improves reliability of command transmissions and makes CBus far more suitable for large commercial applications. Now let's go to see CBus far more suitable for large commercial applications than X10. Profibus, usually styled as a Profibus as a portmanteau for process field bus, is a standard field bus communication in automation technology and was first promoted in 1989 by BMPF, German Department of Education and Research, and then used by Siemens. It should not be confused with Profinet standard. Alright, let's move further now. Now we go to important point of fire suppression system, and that is inertial gases. You know what is inertial gas? It's nothing very new. Inertial gaseous systems, and this reference is written here. Inertial gaseous system is an inert gas, inert gas fire suppression consisting of natural gases and extinguishes fire. It consists of natural gases and extinguishes fire without causing harm to people, property or environment. Now inergen, name says inergen is a patented unique composition of safe gases. Composition of safe gases including nitrogen, argon and carbon dioxide. N2, argon and carbon dioxide that naturally already occur within normal atmosphere. We all breathe in, so it overcomes flames and not people. That's what it says, because in air we have nitrogen, argon and carbon dioxide in certain percentages. These overcome flames and not people. Inergen is designed to detect smoke. Inergen purpose is to detect smoke, release extinguishment gas and suppress fire before any significant damage or before certain significant damage occurs. What is to detect smoke, release extinguishing gas and suppress fire before whatever significant damage could occur. It's designed to exceed requirements of world standard for gaseous fire extinguishing systems. So it always complies with that. That is world standard for gaseous fire, but exceeds its requirements as well. That is plus point. Now what are features of that? Let us see. I'm not going to show any photograph of this because it's already available on the website. You can go and see. Features are powerful and people says powerful and people friendly. Smothers fire by diluting oxygen. How does it work? Smothers fire by diluting oxygen concentration within risk area while it continues to allow people to breathe. Was that dilute oxygen contents? Oxygen concentration within risk area while it continues to allow people to breathe easily. As they evacuate area, environmentally friendly it is, composed of natural substances from atmosphere, and that is inertial system has no pollution, ozone or global warming effect. When components are released, they simply resume their natural role in atmosphere. When components are released, they simply resume their natural role in atmosphere, exempt from federal government regulation, containing no ozone depleting substances, simply resume their natural role and release in atmosphere, exempt from federal government regulations, containing no ozone depleting substances or synthetic greenhouse gases. Energy is exempt from these strict regulations and restrictions. Equipment safe. Unlike many other agents, that can become corrosive and permanently damage electronic components, Energen does not form any corrosive byproduct that can damage equipment in server rooms, data centers, medical facilities, laboratories, or other sensitive electronic environment. What's benefit of this? Then equipment are safe. That's point here. Other gases may do something else, but here is Energen is better because it does not harm. Many other agents can become corrosive, permanently damage electronic components. While Energen does not form any corrosive byproduct, and that can damage equipment in server rooms, data centers, medical facilities, laboratories, or other sensitive electronic environments. And cost is lower, result is lower repair bills and less impact on business in a safer environment for people. There's another reference, you can see Tyco. This is Tyco product, and Energen is a mixture of 52% nitrogen. Just remember this. More than half is 52%, that is nitrogen, and 40% argon, and 8% carbon dioxide. So this is proportion, can remember very well, 52, 40 and 8, which is nitrogen, argon and carbon dioxide respectively. 52% nitrogen, 40% argon and 8% carbon dioxide. However, in event of fire, when Energen is discharged, it mixes with air. It mixes with air present in room to create a mixture that comprises 67.3% nitrogen. So working composition is, during fire separation, 67.3% nitrogen, 12.5% for sure oxygen, that is 12.5% oxygen, 17% argon and 3.2% carbon dioxide. Let's read it again because it's very important. It's working suppress fire, not idealistic one. In event of fire, you can see when it's discharged, it mixes with air present in room to create a mixture that comprises. Now this is nitrogen 67.3%. That's 12.5% is oxygen and 17% argon and 3.2% carbon dioxide. This discharge mixture makes Energen singularly unique. No other inert gas has unique ability to rapidly extinguish fire, yet same time provide a safer environment for whoever person within occupied area by actually decreasing cardiac distress, no heart impact, maintaining arterially blood oxygenation, and mental performance in low oxygen levels. Equally important, unlike some chemical gases fire, suppression agents. Energen does not. Energen does not and could never create a reaction with a fire to create extremely harmful, toxic or corrosive byproducts. Energen has been extensively used throughout the world as a preferred gaseous fire suppression agent for over 16 years, that time of my war, and remains longest surviving halon replacement. So this is longest surviving halon replacement on market to date. Now, cost study may be made, cost and when compared with most popular chemical agents on typical energen does not make up premium floor space. First of all, that's important. Energen does not take much premium floor space as cylinders can be placed remotely from protected rays. Now there's another one in place of Energen or parallel to it, and that we call FM200 trademark fire suppression system. I'm just trying to share with you this information because these are all used while doing coordination on project. So what's FM200TM clean agent, as we call it, and that is also commonly known as HFC. HFC is 227Ca, and this is a clean agent fire suppression for class A, B and C fires and meets NFPA National Fire Protocol Association, Fire Association Standards 2001, and clean agent fire extinguishing systems. Clean agents are fast and effective in suppressing fires, are safe in occupied spaces. That systems, clean agents are fast and effective in suppressing fires, are safe in occupied spaces and do not leave a residue. How does FM200 work? FM200 trademark suppresses fire by disrupting fire triangle. Disruption of fire triangle, and what's that? By disrupting fire triangle is made up of heat. What is heat? Heat, and then it is oxygen and fuel source. So three: heat, oxygen and fuel source, and by removing one of these elements, fire is extinguished. FM200 removes heat or free radicals which interferes with fire triangles chemical reaction to extinguish fire, which interferes with fire triangles chemical reaction to extinguish fire. Clean agent fire suppression systems like ones using FM200 can achieve fire extinguishing concentrations in 10 seconds or less. FM200 advantages. Let us see what are those. What advantage I'm talking of in this case? In this case is FM200 is a clean agent that is safe around people. Therefore, FM200 fire suppression systems are safe to install in occupied spaces. That's number one. Then we have, when FM200 fire suppression system activates, activates to put out the fire, no residues left behind, and it's safe for equipment, electronics, and machinery. Compared to other clean agents like Novi 1230, FM200 is slightly more cost effective. So cost is different. Well, cost effective. It's then because of small amount of FM200 required to suppress a fire, smaller or fewer cylinders are required when compared to other agents. Alright, now FM200. So we have been discussing Energen and FM200. What are disadvantages? We can see when compared to other clean agents, FM200 has a slightly higher global warming potential, GWP, higher global warming potential. When FM200 does not contain halon gas, while FM200 does not contain halon gas, it still uses hydrofluorocarbons, HFC, hydrofluorocarbons to suppress fires. It uses hydrofluorocarbons to suppress fires, which is not as eco-friendly as other clean agents. What is chemical name of FM200 gas? Chemical name of FM200 gas is 1112333 is heptafluoropropane. Heptafluoropropane. It's also referred to as hydrofluorocarbon. 227EA, and is manufactured by Chemours, the trademark. FM200 is a colorless compressed. Let me just put it in different way because I'm not able to read full. So let's little way move it this way so we can. I think it's 170 is better rather than 1. So that's fine. I'll take possession of this. It's okay fine now. What say here? FM200 is colorless compressed liquefied gas. Colorless compressed liquefied gas used to extinguish fire. No signals, unfortunately, is coming now. So it says colorless compressed liquefied gas used to extinguish fires and is a popular replacement of halon. Popular replacement for halon fire suppression systems. FM200 fire suppression systems are pressurized with nitrogen. Waterless, and upon activation, FM200 discharges as a gas to suppress fires. Say what? FM200 fire suppression systems are pressurized with nitrogen, waterless, and upon activation, FM200 discharges as a gas to suppress fire. Is FM200 gas dangerous? That's a question. FM200 is low in toxicity. This is low in toxicity and does not pose acute or long-term dangers. When handled per manufacturer's recommendations, vapors from FM200 have little to no effect on skin or eyes, but when in liquid form on contact, it can freeze skin or eyes, causing frostbite. In case of inhaling high concentrations of FM200 vapors over recommended exposure limits, one may experience headache, dizziness, loss of coordination, confusion, and in a worst case scenario, consciousness, loss of consciousness. And when following manufacturer's guidelines, FM200 is safe for use in fully occupied areas. What is difference between FM200 and other surveys? Then FM200 and other Novik 1230 systems are similar in that they are both safe to use in occupied spaces, do not damage sensitive equipment, and because they both leave no residue. There is no cleanup required, while both FM200 and Novik 1230 are fast acting clean agent fire suppression systems. They differ slightly. Novik's chemicals compound is a fluorooctane, fluoroctane, and is stored as a liquid and discharges as a gas. The system may require larger or more cylinders than FM200 system based on area protected. Both FM200 and Novik cause no ozone depletion and are considered environmentally friendly. However, a Novik does not have a low important one regarding building management system. And building management systems discussed is of course very competitive now. Now we will say something else also here. And this regarding this point is method statement was demanded by certain people at some time. So we regard this very important point. We have to know there's so involved in this. Let's go back to I think we could go back to what's this? We have here. Let's go back to control back and I'll see how does it work. It's okay, actually now coordination engineering and talking of and someone maybe in 3 or 9 will go through. First of all, I like to do something with that let's discuss something here. Have you seen this? This is you can say a plant. This is a plant, and it's a big one. Its capacity at that time was there 600 kTA and 6,000 tons per annum ethylene cracking plant. Portion. It's non-process area. We're talking here. And this is processing area. Processing area where processing is done, and this is support area. This is water collection for cooling, and this supplies to whole plant. And there are certain utilities here. For example, this is substation to supply electrical to this area. There's another one substation. This is the main one, and this supplies to this one. There are so many other smaller areas. So you may say that these are various utilities outside here. There's one building also that's called central control building, and probably I think it's here maybe. I'm not sure here where it is. Somewhere it should be here. Maybe I can't see that here, but it is there somewhere. and it's not in there. There's something building here. I think it's there. Okay, no problem. Go there and see. It should be here. I think this is the one, central control building, and it's blast. Actually, if you think of this complete is blast area, blast zone. This is always blast zone. And you have to keep that in mind. We are talking of this area, and generally says up to 200. I mean, 200 meters of this process area is our blast zone, and more than that up to 600 meters. More than 200, so it is 200, 600 meters. That can be called means like no blast and blast, or you can say blast. You can say this is blast area, blast resistant area. That is also the process area. This blast religion. I mean religions. There is expectation, religions, and then non-blast area. So these are points here. Now in this process area, there are equipments installed, machineries are installed, which are same as equipment, and various other foundations and buildings. For example, as a building, steel building as a building, and there are different type of machines, a lot of boilers, wash water structures. So much is involved there, depending on complete process requirement. And as you can say, yeah, you can say this. You can say pipe racks moving around, going to all these structures. Pipe racks are there. It's really wonderful that so much work is there for cracking gas furnaces and wash water structures. Likewise, many other items are there which can't be seen, but these are there. That might better understand. And here too also we can say what's there. We can see all this. We can central control building, and there's a many other by other people, and it's complete plan package. So this you can say image is 2009, and if you go back and see, it has a flare tower. You can see flare tower, and this pipe rack continues from there. And this pipe rack continues, and this is coming very. You can see it's coming from here. The pipe rack goes on to this flare tower, and also you can say here's a lagoon, water lagoon. Likewise, for structure, and ultimately, so what we can say, what was coordination required in this is important part here. We are interested in coordination and technicalities of that. And coordination doesn't mean you must have other points with that. Coordination is always very complex, but it's very easy to if you can do it. If one can do it, one can make sure I am interested in coordination, I will do it without a problem. And that's a point of interest, you can say. Is a point of interest in that case. We can do it, it's required, and we don't find any problem. That's the point here we have to see. So, in this case, you can say many heavy foundations are used, were used to. Heavy foundations means they are structures were massive blocks. Of course, there were structures of ordinary use. You can say in isolated foundations or independent footings as well as combined. Combined footing is not that much in this, but you can say isolated foundations or independent foundations linked together by beams. So there were many cases as such, and generally on for heavy boilers, heavy machines, foundations there, and for heavy, very very heavy, massive blocks were used. And examples can take for this process, compressor buildings, massive foundations, which you can say is itself a technology to understand how to do that. And example is the RCC buildings, such as substations, RCC buildings, and then there are many collections on some chambers, water, sub water. And these are very significant requirements, significant works. Now it looks as if there's nothing in this now, but It was very complicated work for that. And whole area, you can say whole area, this whole area was brought to levels as a part of site preparation. As a part of site preparation, it was brought to certain profile, vertical profile, so that we can see, means the big requirement of fill up because it was low lying area, and it had to be raised maybe say 1 meter, 2 meter, depending on conditions of rain, intensity of rain. And that we have to understand. There was no rain in fact, but we have to consider that also in this case, and we have to see that what we do, what do you understand, this made up area, not reclaimed, I can't say reclaimed, it's made up, means maybe by how many meters it was made up, and you can say tests were conducted on site because this was desert, deep desert, and after backfilling, what is capacity, how much is required, when it is very millions of cubic meters of well, we can say we can conduct tests on site about compaction of backfill, how many, because it's straight work, how many repetitions are required, how many rolls are required, or how many passes are required to gain, to achieve that FDD, call it field dry density, and these are conducted, and this is forms. So this backfill was done for months together in such a way that area was completely services free. Lines underlying services except electrical interconnections because of its being proximate in vicinity of a refinery. Of course, C is there, C exists, and it's import of gases from offshore. So that was requirement of this. Now, I'm not going to that, but I'm just trying to share the information on its coordination. Coordination is very important, we know. And generally on such big plants, we don't have every information ready, and because of many reasons for that. We don't have that on big plants like this. We had about, here on the scope, RCC works to be done. Designs, of course, not our responsibility. The main contractor's responsibility. As EPC bid, it was to design, and civil works shares was given to us, our people, our company, and it happens that there was some resilience in that as well, you can say. Designers always do designs, and that's also an important point. And constructability issue always exists. Designers rarely think about constructability issues, but that's their job to think as well. Well, it's mindset. Nobody can force anyone, but you can say, I've seen this personally. Fill and then soil bearing capacity tests were conducted. Fill took many months because of his millions, and how many machines could he have depends on that. And it could be both issue when you have a project like this, but you have to have saving. Well, now what I say, as I said, about site preparation technicalities, you have to check, we have to do surveying of area. Whatever you take over, you have to survey area, survey geographically, topographically, and as part of soil investigation, you can go below and find exactly how many levels it was. The points are really important. We have to add this fact. In this was site preparation, a big content exercise, and as I said, it is filled up, and also soil illustration continued, and it was okay. I joined. I was not able to find any information. I spent time on information collection and continuously moved project onwards. Likewise, you can say. So there were ordinary foundations because your bearing capacity recommended by technician or soil engineer was 10 tons or likewise. We did it for other project. Is 3 degrees older. You may say you'll find out that those footings, drawings, machines and utilities drawings were very complex in nature and pieces as well, not one. You can say area wise or coordinate wise those drawings were given and there was no assembly at all of whole areas. Being absent of that absence of that integrity of designs or connections of drawings, we could not, you can say, assume what it was. It's now, and we cannot do that. In fact, 14 degrees now. Let's see back now. What I said is, in this case, let me close this file also. I think this is not required now. Let me put it also save home, and as I close this file, I'd open this. Sorry, I didn't know this. This is open. I'll do this now. Okay. So I close this file also. Why to keep it unnecessarily here? It's taking time saving. Let's take time, no problem. Maybe let's take time saving and what do with that. I was talking about this. Talking about this ethylene plant. I think it is gone. Is it? Is it is gone? Is it where it's gone? I don't know. It shouldn't go like this. I see. I don't know. Wait, actually, what's I don't know what's the problem here, Let's do this. That's doing well, I think. I close this file. This coming in way, and we can say coordination file. Yes, it was here. I could not properly handle it. So I say this very FPS is 6. There's a problem here. And in this case, I was just talking of that we had this plant. Here, this area is full of foundations and these buildings here, and these tanks. You can see these tanks and all area full of foundations. Pipe rack foundations also. All these foundations. All RCC works. These buildings only, foundations RCC, this we can say. Cracking gas or other compressors of foundations which are called tabletops is full RCC, high strength RCC. This was in fact a little energetic to know, and I tried to immerse myself in all these incomplete designs, incomplete drawings, because there were so many drawings were issued, but nothing was final, because there was a reason for that. What happens on such projects, all this equipment are very expensive. If you compare cost of civil works I think it's negligible. In fact, if you compare to cost of planned budget, it's very very little. So what happens? Such contractors who have billions of projects, $1 billion, they don't care for very small amount, but they care for technology. They care for means they don't give complete details, and if you have the time, you have coordinates of designs, stocks, coordinates, and all the locations are known. That's important. We have to do this one. So it was coordination of different type in non-administrative process areas, structures, all structures having basics of designs, and quite good, not bad. And there was, utilities around, and utilities were to be taken care of, and utilities means big problem. Not, if you see those utility plans, there will be so many, and it's not possible to coordinate them on one page. We have to, for sometimes we have many drawings required on one proposal, and depends on then its coordinator. Job of coordinator is enhanced. Job of coordinator is enhanced, and that's a very, very important issue, very important point. So when you have utilities around, you have no confidence, you have no permission. You want to change little coordinate. Maybe if you change little, and there's a problem not from outside, from inside, means you can't do anything. So in that time, I can say, when you have so many utilities, and there may be clashes, there may be various, suppose you may have some drawings built, but that won't work. You may require some clarification. And there were so many changes on current drawings because your vessel was not decided in the beginning. It was decided late. Its designs are given assumingly, based on presumptions, but when these queries were released, everybody was, in beginning known, but later on everybody became so much occupied with that. We had so much problems, clashes, and you can say on that project I prepared hundreds and hundreds of site technical queries, and we had to prepare shop drawings, innumerable sketches. Likewise, if I find them, I don't know where these documents, I'll share with you. And these were very, very interesting one. In a way, these were done. That's why we had to check about these utilities all time. Dedicated person was required, and I was one of them. To me, this site looked very, very small, but size was quite big. And that's the point we have to be serious about. For example, it was, say, around 1.5 or more kilometers, and this was 1 kilometer. You can say how it worked. I mean, you have to take care of all, but the important point is there. So it's a big site, you can say, 2 kilometer by 2 kilometer probably. We have here the provisions of all these concrete works, and cathodic protection also with that. You know what is cathodic protection? That is protection of steel bars from adverse impact of corrosion. And cathodic protection means they have to provide anti-corrosive arrangements permanently into that structure, anti-corrosive arrangement, so that we can provide anodes into that foundations. Anode, that is which allow does not allow corrosion onto steel bars. And moreover, in this case, it is non-epoxy bars, because if you use epoxy bars, which are of course better epoxy bars, then we cannot provide this cathodic protection. But in others where this is non-rust, now we have to consider these points very closely, as I said in this. These substations, all which are in blast area, these were having RCC structures, RCC walls also, RCC slabs, columns, floors, every point. No other structure, no, only RCC blast resistant structures. This is the we have to do something like that in this plant area. Heavy foundations or massive blocks were done. We had specific concrete for this, low heat generating concrete, or we can say GGBS, 70% replacing cement. So this was environment protected concrete, where your temperature does not rise very fast. have to understand these points very well. It's not pictorial alone, it's a factual one. We have to see that fact as well. Factual one is factual one, and pictorial one is pictorial one. Now we go back to this here, and we see how does it work here. You can see. Now what it says, let us see. Process buildings and process area. We are talking of this in this case. We are talking of this process buildings and process area. It's in this processing plant. Yes. Now, what is that? Buildings we have to count, foundations we have to count, and then we can say if there are different structures we have to count. By brag we have to count. All these points are major. Now considering external factors not all for time being, though there are some factors as well. We'll take up at end. If you have complete imposition of knowing all this, we should have clear concept of what we have to do. Because you can enter you have to see from this buildings, which is off-sites and central control buildings and electric substation buildings, RCC foundations, and structural steel superstructures for those buildings and RCC structures for those buildings. For all equipment, structures are required, and you can say all whatever is required is done by this way. Now there is then heavy foundations, we call them, not only normal footings but you can say normal structures, but thick structures and heavy structures, you can say heavy concrete work. Then we have all this formed from pipe racks, RCC foundations and structural steel foundations. We have all process area cover all process piping, process buildings and all process circulations, whatever is required. So work in other areas is easy, in ordinary foundations is easy, there's not much complication. But changes because of design change currently and in future. This more project, especially you can say So all we have to understand this process is very clearly in the contents of this project. It's quite big concrete work, you can say, quite big steel work. Thousands tons of structural steel was used, and you can say thousands and thousands, I don't know, maybe around 100,000 cubic meter concrete is used. It is an interesting one to coordinate these utilities in coordinate landscape, external one, internal one. All this you fell in yet. It's actually over pressure of wind that acts on such blast issues, and this is for few seconds only. It's not much than that. We discuss this later on. But now, what says this tabletops with this very heavy weldings and heavy foundations? It requires attention for purpose of studying and turning and transferring studies. Where is that? We have to consider these points very well. We have to see process area, hours, all process piping, process buildings, and process calculation. We have supporting systems there, all supporting systems for this purpose. Processing area has supporting systems and remote supporting systems like offsites, utilities, etc. Underground infrastructure is very important from various viewpoints that we should keep simple as. But process piping and process buildings, seawater basin, equipment units, and you can say various substations to be constructed around whole area, various utilities, all utilities, we can say all utilities, all pipings, utilities having manholes around. You can imagine about 400 to 500 manholes required to be done. When we have to think like that, there is no other way left but to do that one, and that's a major part of what we think is right, and that's a really important point of view from this consideration. So we just brief that one, and this of course what do we have to say about. Now we go back to our file here and we continue. Ultimately we have certain I'd like to have some discussion on this. It's an important part we have here. There's so many drawings as such. It's uh, it's something we ever do. Something we ever do. Generally, 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 architects and people do not know about this, but system is different. Talking of foundations, foundations being very important element in structures. Foundations, people take it lightly, but I'm talking about everyone. It's taken lightly. Think building stands intact, it's okay. For them, building's life is important only from that is access. Public do not know complications, do not know conduct of concrete or structure. They do not realize where risks are involved, what sort of risks are involved. To be very frank, when we design structures, buildings, or particularly buildings, we take all required loadings. Loadings means building is erected on, this thing is constructed on soil, and what's capacity of soil, that's very important point. If we can say, we have to consider that point. It's very important, we have to understand what are buildings, how these are done. We know building is very important engineering item, and without building we cannot live in houses. Every house is also important because house means a building. It may be house or it may be residential, it may be commercial, it may be whatever type. There are so many classes of buildings, and building is a world which cannot be argued with. When we say foundation, so what does it mean? We have to construct foundation. What's the purpose of foundation? First of all, we have to get that into our mind. What is the purpose of foundation? Somebody thinks somebody thinks another way. But ultimate purpose is just to transfer loads from all superstructure to reach your privacy, to reach your part, as I said. And if you are 100 kilometers away, foundations are not jokes. We have to remember, building is going to be used for many decades, many times, every time I suggest. Building is not an ordinary product, just like other products are. All other products, non-building products, are just for a couple of years probably, and those are not risky. While buildings are risky from various points. We can say every building has certain loads, its own load, we call that load of its own, and we can say load that are imposed on this while using, which called live loads. And there are other loadings, and there are then wind forces, dynamic loading, we can say wind forces, seismic effects, and whatever these are. There's a long list of loads that can be applied, building is subjected to. And because we must have certain dimension, vertical dimension of building or dimension 3D, it should be in such a way that building doesn't remain slender all the time. It does not remain slender, but its clarity is not understood. So why we say, okay, We, we took, we referred to software and designed it. Check this. It takes time. It's a fact. If you consume these buildings properly, if you make them, construct them, we have to understand first of all soil, and then we have to understand how this building is going to behave and going to respect also proposed designs, proposed construction, both marry in this path. So we have to make sure that all foundations, whatever we provide, it may be whatever type of soil, must move down in equal measurement. That is very important part. Make for starting excavation, every profile must be recorded, labels recorded, and book form is in book form. Is there anything else? Okay, now what we have to do here, that we have to avoid settlement. It may be granular soil or it may be whatever soil. Settlement is important question, immediate settlement, and that can cause havoc on structure. Structure is weakened means everything is weakened. We have to be very careful about that. It's not simply I'm saying, it's a fact as well. What to do in that case? In that case, we can say, well, think of different type of foundations, not ordinary one, but you know, foundations which continue to meet other foundations, and each foundation meets with neighbor foundations in a way that you can say integrity of structure is provided, at least to share phones from the fairly connected for some others. In that case, we say, as I showed to you, this section, you can see small foundation section, foundation beam. It is not just a beam, it's a beam continuing over all columns, connecting them. And columns do not come out of beam, but usually they come otherwise. Lux ultraviolet, you can say, or others, whatever come there, have to be registered. We have to be very serious about that type of foundation. because it is very reasonably provided, and it has many better ideas. Soil improvement can be done if required, as a very interest case compaction building, as though built 50 years back but still find it comes suddenly, it can suddenly die. We have to think of that, how to best keep, because there will be vibrations due to system, due to operations, due to earthquake, or it's not necessary. I'm talking of this project or first. When you talk about integrity of foundations is to be maintained, and if an integrity of foundations is maintained, the steel building is okay. Hard steps comes in, hard work comes in. We have to connect all foundations. We start column forms from top of this foundations. We have to relax also in between long talks, right? Don't worry about that. We have that acumen with us. This was done also in my building, as I discussed here, same. Now, beauty of such foundations is that column rise above beam, column concrete starts that beam top over here, you can say. It's not from there. In fact, you can say we can take this beam in such a way that the whole the foundation is covered with beam, and there's nothing else. You can say all the foundation is covered by, you can say, this beam, this whole portion. This keeps air moving around. You can say like this. Foundation's here. You can see clearly. Complete rotation likewise. This is was important point I tried to tell. We have to take sections of columns little wider or bigger than often people do not know. They don't take. We generally consider that in current technology, for purpose of safe structures, it should be stronger column. Column should be stronger than beam. That is major principle, common sense principle, rather than, you can say, written principle, because column is the main element. Column is main element in every building where load accumulates. Load accumulates at every floor. Load means dead load first of all, then live loads, of course instant or accidental loads, like we can say wind loads or earthquake load, or you can say other loads whatsoever, minor one. Whatever loads there are, these accumulate from top to bottom, and some people think that always is risk as bottom, not at top. But people are not clear about what's theory of structure, what is load distribution, how load depends, because it's very unclear to common people, because they are not in this profession, not well educated. More than direct load, we have problems with load of movements. Beam takes load of one floor only, and that's a part only, not whole. All beams share floor load. They share direct loads of that floor, as well as these beams share wind pressure, earthquake pressure, heat, all that. And as I say, beam is a part to support slab, and this becomes a part of frame as well. When load is transferred to beam, it becomes a part of columns and beams, above column and below column and all columns. You can say it's like that. Means every column increases its direct load from top to bottom. And same way, when we talk of bending moments, this term is called bending moment of these beams. What's the purpose of that? When it sags or hogs, sags vertical top instantly, and higher it is upward side. We have to share this information with us and with everybody. How to design buildings. We have to understand buildings rather than just jumping onto software use, because always heavy columns, stronger columns, and less stronger beams are preferred. And we can devise that. Top, always at top floor. Bending moment is wider, bending moment same. Bending moment is the most important point. columns and slabs. So purpose of this coordination is very important here, the structural coordination, and it has your own design system. You can design yourself and it's not a big deal. And important point is that because of reduction of moments in beams, frame beams, whatever beams, even moments are very little in this case because I provide fixed beams, likewise vertical supports, like totally. Well, so better is that steel is also continuous in this beam, and we can use a little diameter pass in whole foundation with many top and bottom main layers and also side layers. So, yes. What important point we can give in this is that we have to understand this theory of beam frame foundations, and we have to provide soil improvement also if it's required, because generally clay soil does not allow good foundations on this, and everywhere graded course graded aggregates are not available. Even this point when we study fill our own soil, those are the down. and it is for time being. I'll be back. must have covered this. In fact, a lot has been covered in this. You must have gone through this. Now I'm coming back to coordination engineering. Coming back to coordination engineering, which is a real requirement of life, and we have to see how we move in that, as because coordination engineering is a must in every project we say, and this is because of quality issue. We have to achieve quality, and that's our important point. We have to come out of this problem. We have to come out of this problem of quality engineering and coordination engineering. And it's an approach on working designs, a must in manufacturing and construction procedures. We must continuously do assessment of working consideration for quality goals, always say. And in this country, we have to do it. We have to fix quality in our country, India, Bharat. Whatever happens, whatever comes, we don't care. We have to do it. We have to achieve it. There is no question of any excuse. And we cannot compromise with any work without quality. And we don't intend to compromise just in the name of fragile systems. We have to think of quality issues, because quality has not to be allowed to be failed. It has to be kept intact. But first of all, we have to do it. Only then we can say just to be kept intact. It is not happening. We have to consider that point, and we have to ask questions ourselves. Where does quality exist? Where has it gone? I don't find it. I have to find it. I have to resolve it. I have to think on this. And can we say we bring working environment to quality and coordination requirements? How to do that? And we have to think on this. We have to confer on this every time. We remind ourselves certain red lines that must be turned green, and that must be a must, and we cannot avoid that one. And we can say, can we know how to do it? How to do it? This question is done in other countries, particularly in many countries of GCC and Middle East. We can see there's a huge quality issue. In some countries it doesn't. It depends on whether we find oil plants constructed, where facilities are constructed, like ethylene plant. Quality issues, of course, to some extent are acceptable. We cannot deny this fact. In buildings also there are controls, various controls, of course. In many buildings don't, but in general it is there, it exists. So why say that can we work on coordination activities to achieve defined or expected quality profile in works, and that's coordination engineering I'm talking of. It's very important one. And coordination means we must get correct information, right information, like time, that must be provided to person or those supervisors who are responsible for work. Why we should not revisit quality required specifications? We should read again and again. If we really can't understand specifications, we can't implement that. And for that, we must have knowledge, we must have ideas how to move with that, and that's really very important point. You can say why we should not revisit quality required specifications and update per world working standard requirement. Why should we not apply coordination requirement? This is not a must. Question is that really we have certainly worsening state of quality of works, worsening state of quality of works. How to improve such mandated works quality to certain minimum required marks, at least to match with minimum international requirements. Should we not force ourselves to work on coordination in each activity? And that's really very important one. Worsening state of quality of concrete. This worsening state of quality of concrete and how to improve such mandated quality to in certain minimum required marks. Big question mark. Worsening state of quality. Worsening state of quality. I am calling worsening state assuming there exists quality, but there exists no quality, so it's not worsening, but non-existing state. I should say non-existing state of quality of concrete and how to improve such mandated quality, such required quality that should be mandated to certain minimum required marks. Minimum required marks I'm not saying maximum. And if we can't achieve minimum marks, what sort of people we are, you know that. It means it's a blame on professionals, it's a blame on contractors, it's a blame of supervisors, consultants, and everyone. It is indirect impact on them. It is indirect attack on them, professional attack. Now we say concrete component in construction amounts to major percentage of cost of, and therefore it becomes incumbent on everyone to care about quality of such component. That is concrete. As I say in title, I say concrete. Concrete as material and concrete as state of existence both. Concrete as material I'm talking now, and as concrete component in constructions amounts to major percentage of cost, and therefore it becomes incumbent on us to care about quality of such component. It's of course out of common and professional understanding that why do have no seriousness in this regard. Where has that profile of being serious gone to? Why I'm calling we are not serious? Because we are not serious, we are free-minded. We don't take life seriously. We have become easy, we have become comfortable in living, and we don't care for what's happening, and particularly in concrete. And I say just I'm telling concrete, but it's in every place. Every place quality is downing. Even if you take examples of electric bulbs, LED we call it. They say a lot about this, but if you see these bulbs don't function properly, what to do? And that's an example. So we can say here what SMOLS is: worsening state of communication and coordination. I should again say it's non-existing state of communication and coordination that happens during work of engineering designs and executions or construction activities, for which we can say role of engineers come into play, and that role is absent. And that's why I again say on files of on files of on files of you can say on files of coordination, as a coordination engineering which is a must in every project. Again I say starting designs, construction, controls, so very absolutely interrelated, required sections for achieving from successful start to completion of a project, which all must be applicable throughout project stages. The all works be smoothly effective. These these sections or stages, plannings, categories of working are initial conceptual designs, designs for works execution purposes, procedure implementations, about how to chart out construction of designed project works, project construction works, currency, decision, and works carrying out. When I say currency decision, this doesn't mean note currency. It is construction works duration of project, that's called currency, and whatever decisions we make and works carrying out we do with whatever is done, testing, completion, and commissioning, launching, use of project, whatever. When project title terminates at that moment and renaming is done to that to operation occupation, this means the designs may be considered oversafe sometimes or optimum, but in fact reality is different. Real construction involves actual expenses. We have to remember it requires contract time, it requires financial liabilities, and building's professional reputation is also remains at stake, is also at stake, which all must be cared for sincerely. But both stakeholders of such honor an engineer, designer at design stage. Therefore, should be made motto, an objective of an organization to apply good controls on project so as to keep in line to on schedule planning being an actual part of controls. Control includes progress, cost escalation, time, budget, quality requirements, assurance. I speak actually requirement. I don't have to use assurance because I'm not going to assure anything. I have to do requirements delivered. That's my principle. I don't assure anyone because assurance got no meaning. It should be delivered, confirmed delivery. Coordination engineering as well as total engineering, and safety, risk covering and delays, recoveries, can say. These are all integrated divisions. These are all integrated divisions which should be in unison. Just a minute, please. Okay, then we say well designed. So these are all integrated divisions. They should move in unison to achieve project delivery target. A well designed project could be jeopardized during construction phase. From budgetary viewpoint, should it not be given due required control application properly. That's what I say. A well designed project could be jeopardized during construction phase. From budgetary viewpoint, should not be given due care, due required controls application properly. What it says is, मैं रख देता हूँ ना. A well-designed project could be jeopardized during construction phase. From budgetary viewpoint, should it not be given due required care, due required controls application properly, without organizing with full intensities. Keeping eagle eyes on project and construction controls, no project can be delivered in time and fixed budget. First act of project leader therefore must be to get into allotted budget and then to move project within its defined ambit. In absence of project parties, there can be no virtual control, there can be no real control. And when there is no real control, means we cannot control anything. One should remember, once money is lost, it cannot be regained. One should know, once money is lost, no possibility exists to retrieve that lost money back. Because money is spent and nothing is coming out of that until project is delivered. Analytical tools can be required. Analysis tools can be required to operate with complete dedication to carry out or conduct controls. All required sections, related activities import total dedication. All required sections, related activities import total dedication. From quality input within such disciplines and actions as well as in works. Oh my God, voices are too many. Dogs are barking. This other voice, this is disturbing. I think I will not record clearly. It's very disturbing. Let's just review what we have done. So we can say we have reviewed something that is extraordinary today. I take into consideration energy system and FM200, which are very important part of fire suppression, not loss prevention but fire suppression. And we have talked a lot of coordination and quality, and therefore we can say we contributed something to ourselves, to engineering profession, and to let people understand what's required, what's not required. It's really a very important part you have to think of, to do of. A lot of there in coordination file, a lot will be added. No one can deny that fact. You can see it goes on moving and moving. I'll reorganize these files here just only for information, and currently taking it with you. More information added depending on knowledge. I cannot take technical issues because the purpose of this file is to let people know what's coordination value and how, because engineers are not caring of coordination, I understand. What's constructability, what is buildability, what is coordination, what is analysis, what is thinking, what's supervision, what's quantification.